Hello, I'm Keith Kreischer of the IoT M2M Council, or IMC, and I'm here at the inaugural Embedded World North America exhibition in Austin, Texas, talking to my good friend Martin Jefferson of Globalstar, satellite services provider. Martin, welcome.
Thank you.
How are you finding the show, first of all?
It's actually very interesting. I've met a lot of new people here that I wasn't quite expecting. Traffic's been quite good.
Wow.
And of course, beautiful Austin. It's nice weather outside. Come from Canada, so the sunshine is always welcome. So.
Hey, these days, we're hearing a lot about convergence when it comes to connectivity. Satellite converging with 5G, satellite converging with low power. You know, that's all well and good, but what are the business drivers that are really pushing all that? You know, why is it happening?
Yeah, so generally speaking, I mean, we use a term in our industry called ubiquitous coverage. And people are literally demanding connectivity wherever they go. What they don't necessarily realize from an infrastructure perspective is that connectivity only exists where infrastructure exists. So if you think about it from a terrestrial perspective, networks are there, towers are there, frequencies are there, but when the population doesn't exist in a particular region or zone to justify the cost of the infrastructure, then you start looking at alternate technologies like satellite, like Wi-Fi, like LoRaWAN, some of these other technologies that are out there. We're getting forced, quite frankly, into the connected world on the satellite side of things because it's a good extension from a terrestrial perspective. Some of the small packet data usage on the terrestrial side of the business also bleeds over well into the satellite space, and because we've got infrastructure already in place, then it's a natural progression to go that direction.
Right. Talk to us about the unique characteristics of satellite-centric non-terrestrial networks versus terrestrial networks in terms of the architecture, in terms of the performance.
Yeah, so the big primary difference is that our infrastructure is all in the sky. And we are forced every 15 years or so to replace that infrastructure in the sky. So adding technology and having that technology move throughout that 15 years is a very difficult process. It's very capital hungry to be able to put those birds in the sky. So we find that the terrestrial world, from a technology perspective and an adoption perspective, moves at a much faster pace than the satellite world does. So what does that mean for us? Then we need to make sure that we can take a piece of the business, right? Because we're talking about a 90-10 piece of the business, 90% terrestrial, 10% in the satellite world. We need to be able to fit that into a network that is very frequency sparse. So frequency sparse means in the terrestrial world you can reuse channels over and over and over again. In the satellite world you can't do that. We all have a finite amount of spectrum, and there's only so much data you can move over that finite amount of spectrum. So we need to be very, very focused on making sure that the device technology and the device standards that is being worked on right now, the 3GPP standards, takes more into consideration the satellite portion than the terrestrial portion, because we are not nearly as agile to change as we go forward.
When you're talking about convergence, I should say, of 5G and satellite, what are the potential cybersecurity challenges there? I've got to believe there are some.
Certainly. So obviously the more networks that are involved in any sort of data transaction, the more potential places there are for intrusion, right? So if you fast forward to the magic NTN world where everybody's device just roams on everybody's network and you have all this coverage wherever you go, what we're going to have is you're going to have more opportunities for cyber terrorists to get into networks and exploit networks, and you can actually do it through the back door. So you can have a perfectly great 5G network that is lock solid and is protected from the outside world, but if you bring in a partner or an NTN device that has some kind of security vulnerability in it, you're basically opening the door to that private security network.
You're expanding the attack surface.
Exactly.
Right. Interesting. We're doing a lot of work at the IMC on security right now, talking to regulatory bodies, talking to standards organizations, really just embarking on an entire program, trying to cover all three layers of the stack, so not just device, but also networks and platforms APIs and cloud. It's a huge effort. Are you hearing a lot about that here at the show? I mean, and generally speaking, I mean, is security becoming more of a topic?
Certainly is, right? As they always say, the lock on your door only keeps out the honest people, and obviously people, as we get more and more connected devices, now we're into connected fridges and stoves and things like that. These are all, vulnerabilities to get into networks and to actually do harm. So we're actually seeing more and more segregation in some of the software side of things to be able to protect core operations that aren't accessible to the outside world. I just had a great conversation with the BlackBerry guys today about how they take and don't give access to the kernel portion of their software, and then that's really the core of everything, so everything else is monitored outside. It's auxiliary to that. I think that's a really unique approach, and I think that's something that people are demanding nowadays.
Talk to us about future trends. I mean, security is one thing.
Sure. Future trend, obviously, when you talk about a ubiquitous coverage device, you're talking about coverage, you're talking about infrastructure, you're talking about cost. So we do talk a lot about the race to the bottom in this business, right? Things get cheaper and cheaper and cheaper as the networks evolve. Somewhere we've got to find the synergy, particularly in the satellite world and the terrestrial world, because the satellites are always going to be very, very capital hungry, right? You have to replace this infrastructure at least every 15 years as they run out of fuel, and you can't refuel them. So you're replacing an asset that has a very short lifespan from an infrastructure perspective. And I think what we're seeing is there's a push to pull the price down, but there's a push back from the network providers like ourselves and others to say there's got to be a balance between the two. So you take a feature set of 5G where you have virtually limitless bandwidth in our world anyway, the satellite world, and you have to marry that with a technology that is not quite as advanced and is actually a lot more expensive to run. So there has to be a balance between feature sets, I think, in the network capability to make it more something that can be adopted worldwide.
And here at the show, are you finding people that are as sophisticated as you just laid out, talking
Very
about?
much so, very much so. In fact, speaking well over my head still.
Really?
Some of the people.
Interesting, because
Yes.
that's one of the things we found within the embedded ecosystem. People are getting much more savvy about connectivity.
Yes, I think you have to.
Yeah.
It's a fact of life, right? Everything is, and it's just expected, right? It's an expect, and when you don't have connectivity, people scratch their head and like, well, why not? I don't understand.
Terrific stuff.
Yeah.
Terrific stuff. Speaking with Globalstar and Martin Jefferson here at the IMC's IoT Pavilion on the floor of Embedded World North America, the first show in this country. Martin, thanks so much for joining us.
Thanks very much, Keith.
And thank
Great
you.
to see you. Thank you.